Hello, we are back with section 5.5, the substitution rule. So now we saw how to integrate different functions, and we saw how to sometimes we have to manipulate the given function and the given integrand, and in order to get it simplified and so that it matches one of our integral in the integration table. Now, but there are situations and sometimes which we cannot simplify things the way using direct algebra, like distribution or exponents. So then we have to think of some other way to solve the integral. Here we are going to talk about substitution rules. So this substitution is called U substitution, but it doesn't mean that we have to definitely use the U for the substitution. We can always use any other letter. Okay, so here, inspiration for the substitution rule, we look at this example, this one. So if you have to integrate this function, it should be easy to do that, right? How would you do that? Well, you will take the expand this term as quadratic expression. So it becomes x to the fourth, actually the fourth degree of polynomial, minus x to the fourth minus 4x squared plus 4. And then we multiply it by 2x. So we end up getting integral of 2x to the fifth minus 8x to the third plus 8x dx. To integrate, we get 2x to the 6 over 6 minus 8x to the 4 over 4, then plus 8x to the 2 over 2 plus c. Simplify, we end up getting x to the 6 over 3 minus 2x to the 4 plus 4x to the 2 plus c. So we have been able to solve this. But what if you have something like this? Instead of the second power, you have the 50th power. You are not going to expand this, right? Even if you know the Pascal's triangle, trick, it is going to take a long time to expand this expression and then multiply it with that and then take the antiderivative. So we are not going to indulge into that. So we are going to look at some new method. In this method, what we do, we make a substitution. We take some expression in the integrand and set it equal to u. Well, again, as I said, you don't have to have u. You can set it equal to t, z, w, v, any letter except x, because x is being used here in the expression. So if you are using t here, then you can use x. But mostly people use u for this kind of substitution. I'll go with the u, but we can have something else as well. Now, so how do we pick the u? So the steps for the procedure or for this rule is to apply the rule are, first step is to pick u. That is the first thing we have to do. Okay, by the way, why will we use this method? That is the first thing that you should be interested in, or you should know, that you try to look at your expression or the integrand and try to see if it fits our table. If it doesn't, then you think about, okay, can I do it some other way? Can I distribute? Can I simplify, factor and simplify, things like that. So if it doesn't, you cannot do any of those things, then you should think about u substitution. And also there are some questions, some problems which by just looking at those, you kind of get the idea that you need to do a u substitution. So what will be your u? So usually u is the expression that is inside something. So inside a square root, inside a power, inside a trig function. So in other words, because we are talking about inside and of course there is an outside, so this is referring to the chain rule or the composition of function. So the another tip is that u should be inside something. So if you see inside something and then there is some power, so this quantity should be the u. If you have square root and there is inside here something, this should be, the whole thing should be your u, and so on. Now another thing that you have to remember is that the derivative of u should be present in the integral somewhere. It should be being multiplied with the inside the integrand. So this is how you pick u. So once you have the u, think of the integral in this form actually. If you can think of the integral in this form, that your function, your integrand is looking like f of g of x. So some composition of function, and then the derivative of the inside is being multiplied here in the integrand. Then your u will be this function inside g of x. Once we have the u, we pick the u, whatever the function is, then the next thing is to find du. So in order to find du, if you recall, if this is like differential, though we are kind of differentiating both sides, but we only put the differential there. If you do not understand this, I will show you another way to do this, but this is what I'm doing. So du will be equal to the derivative of g of x, the derivative of the function that we took from inside, multiplied by dx. And from here we will find our dx. So for that we will divide both sides by whatever we got here, g prime of x. So dx will become du over g prime of x. Now we will do the substitution. So substitution means wherever we have g of x function, that will be replaced by u, and the dx will be replaced by this quantity. And if there are other x's around, they will just stay, and then you will see that things eventually simplify and we get the integral all in u. So all x's must be eliminated. This is very, very important. All the x's must be eliminated, so that the integral is of this form, the sum function of u times du, and also it must be simpler, much simpler, so and is easy to solve. That is, it is in our integration table. Once in a while it will happen that you still cannot see it in the integration table, so you may have to do a one more substitution. Okay, once we have it in terms of u, now we do the anti-differentiation or the integration. We integrate this function, which should be easy to be integrate, and once we do that, our answer will be in u. So what we do last thing, we resubstitute the x, so we go back to x. That's how we. So let's look at this example 2 that I showed you up there. So what will be our u? So can you see a quantity inside? And sometimes it will happen that you will pick a wrong u. That might happen. So it's okay, because very soon you will see that that won't work. So any u you picked, if it makes the integral more harder, more complex, then it means your choice of u is not correct. You pick the other thing as u. For example, here we see two things. We have this expression, x square minus 2 whole to the 50, and then we have the 2x. So will we pick 2x as our u? If I pick 2x as our u, how will I get rid of this x? It will be hard to do that. So what we do, and also 2x is not inside anything, so that shouldn't be the u. The u should be, so let u equals, as you can see, can you see x square minus 2 is inside the power 50? So this is kind of a composition where g of x is this and f of x is x to the 50. So this is the composition function. And then when you have the u is equal to x square minus 2x, the next step is to find du. So du will be equal to 2x dx. Do not forget this. This is very, very important. Because the next step you will do is find this dx. So you will divide by 2x both sides. We end up getting dx is equal to du by 2x. Now we go and plug these in our integral, and we end up getting u. Will the 50 stay there? Yes. So u to the 50 times 2x, so 2x will just stay there. Dx is du over 2x. What do you see here? The 2x and the 2x get cancelled. So our integrand is looking like integral of u to the 50 du. So see, this is very, very important. If we didn't do this step and we didn't find the dx, we will have a dx here, and then you cannot solve. You cannot solve the integral. If you have a dx here, you cannot solve the integral. Okay, so this must be u. That's why we found dx. And also, if we had not found if we had not find the dx, then our expression would look like this: u to the 50 2x dx, which is something at certain level in Calc 3 you will learn about double integral, but here you cannot do this. So remember to do the du thing always. So this simplifies it to u to the 50 into du, which is u to the 51 over 51 plus c. So we see, so easily we were able to integrate it. But now what we have to do, the last step, we have to substitute back. So this will be equal to x square minus 2 raised to the 51 divided by 51 plus c. Okay, so remember, u is the inside. So u lives inside something. The next example, x to the 4 multiplied by cube root of 3 minus 5x to the 5. So what should we pick as u? Something that is inside. x4, is it inside something? No. Well, x is inside something, yes. But the thing is, if you pick u is equal to x, then you are not changing anything. The only thing will change will be, instead of x, there will be a u. Du is dx, so dx will be changed to du. So the expression won't change. So x is not a good choice for u. So try the other one. Well, you see, this is inside something. This is under the cube root. Let's say this is u. 3 minus 5x to the 5. Differentiate the derivative of the right hand side is negative 25x to the 4. And over here, du. And what am I forgetting? Dx. So do not forget dx. And then dx will be du over negative 25. So negative I will put here 25x to the 4. That is our dx. So we come back here now, plug in. So x4 will just stay. This will now be u cube root of u. And then I have negative du over 25x to the 4th. Note here now, the 25 will stay, but the x4 and the x4 go away. So our function, our integral simplifies to, I'll take the negative 1 over 25 outside. Inside I have u to the 1/3 times du. So negative 1 over 25, or it will be u to the 4/3 over 4/3 plus c. So see how the integral became so simple. So this is equal to negative 3 over 100 u to the 4/3 plus c. Look at this one. This is saying 1 over x square minus secant square by x. Now, this is, we can easily use our properties of one of the properties of the indefinite integrals, which says that the integral can be distributed over a sum or a difference. So you can see that you will need a substitution over here, but this is not something which we see in our table. So now we separated it. This one, the first integral, I can write as x to the minus 2 dx minus. Now in this second one, I'll need substitution. So on a side, we will do that. Always remember, try to do this substitution on a side. Don't do it over here, because it becomes, it doesn't look organized, and it becomes messy, and it's hard to read what is happening. I mean, you may not go that far to the right. Maybe you can stay a little bit to the over here. U equals pi x. Then du will be equal to pi dx. Okay. So I'll do the substitution. Oh, by the way, dx is du over pi. So I will do the substitution in this one, and it will give me one integral secant square u times du over pi is equal to, now this will be, the antiderivative will be x to the negative 1 over negative 1 minus, I can bring out 1 over pi, I am left with secant square u du. But what is the integral of secant square u? Tangent u. Now this, the first expression I can write as negative 1 over x minus 1 over pi times tangent of u plus c. We are done. Last thing to do is put back the u. We have negative 1 over x minus 1 over pi tangent of pi x plus c. Okay, I'll let you try these next two, and then I'll come back. So try them. I'll see you in the next video.